All right, so on these absolute value inequalities, again, your first job here and your most important job is to make sure that you decide what type of inequality it's going to be. So in this one, we have a greater than sign. And we talked about this last week. We have greater than. Think of it as a great or. So this is going to be an or inequality here. So to set this up, you're going to have 4x minus 12, and this is the tricky part here, is less than negative 16. I know we're starting off with a greater than sign, and now I'm changing it to a less than. All right, but again, the numbers that are further away from 16, like negative 17, negative 18, negative 19, that are further away from 0 than 16, they're all less than negative 16. Or the easy case is 4x minus 12 is greater than positive 16. All right. So on this one, we got 4x minus 12 is less than negative 16, or 4x minus 12 is greater than positive 16. So you need to create this. And then solve it. So we have 4x minus 12 is less than negative 16, or 4x minus 12 is greater than positive 16. So we're going to solve these. We're going to add 12 to both sides. So I have 4x is less than negative 4. Divide both sides by 4. Again, don't flip any inequalities here. We're divided by positive 4. Or 12. X is greater than 7. Then you got to graph it. And that's it. All right, so again, your main thing here is just making sure you get it set up correctly. If it's a greater than or equal to, it's going to be an or inequality. The equal to stuff doesn't matter here. It's not going to affect, what type of inequality you're going to set up. So next up, I want to go over one where we got to isolate the absolute value first. So next up, we got 2 times the absolute value of x minus 3 plus 11 is less than or equal to 27. All right, so the first thing we got to do here is isolate the absolute value of x minus 3. To do that, I'm going to subtract 11 from the left and from the right. So I get 2 times the absolute value of x minus 3 is less than or equal to 16. Divide both sides by 2. Now we're ready to decide what type of inequality this is going to be. So it's a less than or equal to. So this is going to be an and inequality. We're within 8 units of 0. So I get x is greater than or equal to negative 5 and less than or equal to 11. On the graph, it's going to look like this. All right, so there's a good example of an or inequality, and then a good example of an and inequality, and also having to isolate the absolute value first. But again, the big thing is getting that inequality set up that you have to solve. All right, so then the special cases that you saw, and we only got to go over these a little bit in class. All right, so first up, you got a negative and an absolute value. That's really the thing that sets off the alarms first here. Okay, that's no good. All right, but in this case, 2x minus 9. Okay, absolute value of 2x minus 9 will always be greater than or equal to 0. Okay, so what I mean by that is whatever x value I put in here for x, the smallest I can make this is 0. Okay, 0 is greater than negative 4. Any other number, like if I get like negative 800 in here, absolute value makes it positive 800. It's never going to be less than negative 4. All right, so there are absolutely no solutions to this inequality. Okay, so if you get the absolute value is less than a negative, no good. There are no solutions. If you get the absolute value over here, though, so again, absolute value of 2x minus 9, I'm just going to rewrite what I just put there, will always be greater than or equal to 0. Okay, so it's always, like the lowest it could be is 0. 0 is still greater than negative 4. All right, so all real numbers will be solutions. Okay, so that's a good overview of, like, I think I try and tie up any loose